Good afternoon, everyone. Welcome back to NEET Elite. Hope all of you are doing great, having the good time at home. People, if you guys are super excited for the today's session, again, just hit the chat box with the thumbs up so that I get to know the Josh in the today's class. Let me know, guys. Let me know fast in the chat box. Just hit the chat box with the thumbs up. Wonderful, guys. Great, great, great. Wonderful, wonderful. Let's kill the session today, yeah? Let's kill the today's session again. Yeah, exactly. The Josh must be high. Josh must be high. Wonderful. Exactly. Great, great, great. All right. Yes, Namrata, I remember you definitely. Yes, I do remember you. Wonderful. So, people, in the today's session, we are going to talk about the Charles law and the Gay-Lussac's law. Okay. In the last session, we talked about the Boyle's law. We did some basic things like pressure, volume, temperature. Okay. Then we saw some curves. And at the end, we talked about the Boyle's law and all the curves which were related to the Boyle's law. And people, in the today's session, we are going to talk about the Charles law and the Gay-Lussac's law in detail. Okay. All right. So before starting, as you all know, I am supposed to introduce myself. All of you must be knowing now. My name is Wassim Sir and I am your chemistry master teacher over here. Okay. Well, people, talking about the schedule for the week, as you all know, in the previous session, in the first session, we did the Boyle's law. And today we are going to discuss the Charles law and the Gay-Lussac's law. And in the upcoming session, we are going to talk about the Avogadro's law and the ideal gas equation in detail. This is going to be our schedule for the current week. Okay. Now, people, as we all know, before starting, what are we supposed to do? We are supposed to like, share and subscribe at the same time so that everyone gets benefited out of these lectures. Just hit the chat box if you did it. Just hit the chat box with a thumbs up if you did all this. Tell me, guys, fast. Tell me, I'm waiting for you. I'm waiting for you. Do it fast. Do it fast. Exactly. Jashika, what's up? How are you? Wonderful, guys. Wonderful, wonderful, wonderful. So let's get started with the first topic of the today's discussion, which is what we call as the Charles law. Okay. Now the point is what this Charles law is all about. Let's talk about the definition of this Charles law first. Then we can do some calculations and graphs related to this Charles law. Okay. So people, let's get started with this Charles law in detail. What its statement is all about, what this Charles law is all about, that's what we have to see. See, guys, as per its simple statement, as per its statement is concerned, you can have a look. For a fixed amount of a gas at constant pressure, volume is directly proportional to the temperature in Kelvin. This is the simplest statement of the Charles law. Let's try to understand this Charles law a bit more in detail. Have a look, guys, have a look. See, guys, see, as per Charles law, for a fixed amount of gas at constant pressure, volume is directly proportional to the temperature in Kelvin. What do we mean by this? Have a look. For example, I'm taking a container over here. Let's say this is the container which I'm taking, okay, and I'm fixing one piston on the top of the container. This is the piston on the top of the container, and this is the movable piston. It can go up, it can come down as well, okay. Now, what am I doing is, I'm keeping some gas molecules inside this container. I'm keeping some gas molecules inside this container. People, first of all, the container is closed on all the sides. It's closed on all the sides. That means I'm keeping the amount of gas fixed. I'm keeping the number of moles of gas fixed in the container, right? So I can say number of moles of gas are constant right here. Number of moles of gas are fixed over here. Okay. But at the same time, this Charles law, it's valid only at constant pressure, you can see. So what does that mean? I have to keep the pressure of the gas fixed at the same time. I do not have to let the pressure of the gas to change, right? So the pressure of the gas has to be fixed. Pressure of the gas has to be fixed. Pressure of the gas has to be constant, right? Right? Now, people, I can use my Charles law over here. See, for a fixed amount of gas at constant pressure, at fixed pressure, I do not have to let the gas to change its pressure. That is the first condition which we must satisfy over here. Okay. Now people, as per your Charles law is concerned, for the gas, for the fixed amount of gas at constant pressure, volume is directly proportional to temperature in Kelvin, right? Volume of the gas is directly proportional to temperature in Kelvin. What does that mean? See guys, it's a very simple statement. What does that mean? If I'll increase the temperature of the gas, what will happen to its volume? Volume of the gas will increase. Because both are directly proportional to each other, right? If I increase the temperature of the gas, volume of the gas will increase. And similarly, if I decrease the temperature of the gas, volume of the gas will decrease. Provided the number of moles and the pressure of the gas are kept constant, they are kept fixed, right? This is the condition. Okay, I'm sure this is clear to everyone. So what am I going to do is, for this gas which is having constant number of moles, fixed number of moles, and this gas is kept at constant pressure, if I'll increase its temperature, what will happen? The piston will start going up. What will happen because of that? Volume of the container increases, and if the volume of the container increases, I would say the volume of the gas will increase. So with the increase in temperature, the volume of the gas increases, provided the number of moles and the pressure of the gas are kept constant, are kept fixed. Okay, this is the simplest form of the Charles law. This is the simplest definition of the Charles law, right? Have a look. Volume is directly proportional to temperature in Kelvin. I'm sure you're clear with this definition. Just hit the chat box with a thumbs up if it is clear, then I can move ahead. Just hit the chat box. Fast. Wonderful guys, wonderful. Now have a look on what I'll be doing now. See guys, have a look guys. I got to know, as per the mathematical statement of the Charles law is concerned, I got to know volume of the gas is directly proportional to the temperature of the gas in Kelvin, provided pressure and the moles of gas are fixed, are constant. Okay, now I can remove this proportionality sign over here, right? I can remove this proportionality sign and I'll put the equality sign and the constant over here, okay? And then we have got temperature in Kelvin. This K over here is what we call as, Charles constant, right? We call it as Charles constant. Okay? V is equal to KT. This is going to be our basic equation for the Charles law. And remember one thing, whenever I need to plot any curve related to Charles law, I will be always using this basic equation of the Charles law. Okay, number one. Number two guys, have a look. Have a look on one more thing. See, if I'll use this equation, can I say from this equation V divided by T is going to be constant all the time? V divided by T is going to be constant all the time, right? I can say that. Like we had in the Boyle's law, P multiplied by V was constant all the time. In the same way, in the Charles law, V divided by T is going to be constant all the time. If I'll change the temperature, V by T will not change. If I'll change the volume, V by T will not change. V by T is going to remain fixed for a particular gas kept at constant pressure, having the fixed amount of moles, right? Now guys, see what I'll be doing now. For example, I'm taking one container over here, and this is the piston which is fixed on the top of the container, right? Let's say I'm keeping some gas molecules. Inside the container, right? So basically, I have got the fixed amount of gas inside it because the container is closed on all the sides. There is no leakage at all. So number of moles I'm keeping fixed. And at the same time, I do not have to allow the gas to change its pressure. I have to keep the pressure of the gas fixed at the same time. Okay, let's say when the number of moles and pressure of the gas are fixed, let's assume at that time the temperature of the gas is, let's say, T1 Kelvin, and when the temperature of the gas is T1 Kelvin, let's assume its volume is V1. Let's say when the temperature of the gas is T1, its volume is V1. Okay, now what I'll be doing, if I'll change any one of the parameter among the two, if I'll change any one of the parameter among the two, the other one will get automatically changed. The other one will get automatically changed. What does that mean? As per Charles' law, volume is directly proportional to temperature. If I'll change the temperature, volume will change, right? If I'll increase the temperature, volume will increase. If I'll decrease the temperature, volume will decrease, right? So if I'm changing the temperature of the gas, for example, I'm taking it from T1 to T2, right? I'm changing the temperature of the gas. So can I say volume of the gas will get automatically changed from V1 to V2? Right? So initially, the temperature of the gas was T1, its volume was V1. I'll be calling this as the initial state of the system. Right? Now people, I have changed the temperature of the gas, and what happened? Volume of the gas automatically changed from V1 to V2. I'll be calling this as the final state of the system. Okay? Now people, have a look. Can I use this Charles equation? Can I use this Charles equation for the initial and final state of the system differently? I can do that. If I'm using this Charles equation for the initial state, I'll be replacing V by V1. I'll be replacing V by V1, and I'll be replacing T by T1. It's going to be constant, right? Let's call this as equation number 1. Let's call this as equation number 1. Similarly, first of all, this is the Charles equation for the initial state. Similarly, I can write the Charles equation for the final state as well, and for the final state it is going to be equal V2 divided by T2 is equal to K. This is the Charles equation for the final state, and I'm calling this equation as equation number 2. Right? Very, very simple. Now from equation number 1 and equation number 2, V1 by T1 is equal to K, V2 by T2 is equal to K. Can I simply say V1 divided by T1 is going to be equal to V2 divided by T2. But this equation will be only valid if number of moles and pressure of the gas are kept fixed, are kept constant, right? This is something which I want you guys to remember from now onwards. As per Charles' law, V1 divided by T1 is going to be equal to V2 divided by T2. Just hit the chat box. Just hit the chat box if you got it. Just hit the chat box fast. Hit the chat box fast. Hit the chat box with a thumbs up, guys. Hit the chat box with a thumbs up if you got it. Wonderful, wonderful. Great, great, great. Great. Thank you, Rama. Thank you. All right. So let's move ahead. And let's talk about some more important things related to this Charles law. Okay? Have a look, guys. Have a look. The first curve which I'm making over here for the Charles law is between volume and temperature in Kelvin. Can you tell me what will be the nature of the curve for volume versus temperature? Can you tell me? I'm giving you some time to have a look on it. Can you tell me what will be the nature of the curve between volume of the gas and the temperature in Kelvin as per the Charles law is concerned? You can definitely say that, right? You can definitely say that. Correct. Wonderful, wonderful, guys. Now have a look how I'll be doing it. Have a look, guys. Okay, see, I told you in the last session, whenever we need to plot any curve, we'll be always using the basic equation, correct? What is the basic equation for my Charles law? You guys will be remembering that. The basic equation for Charles law is V is equal to K multiplied by T, where K is what we call as Charles constant, and this temperature is in Kelvin, right? Now people, simple thing, I'm plotting volume along y-axis. I'm plotting volume along y-axis and I'm plotting temperature along x-axis, right? I'm plotting volume along y-axis and I'm plotting temperature along x-axis. So instead of this volume, can I simply write y? Definitely. Instead of this volume, I can write y. Instead of this temperature in Kelvin, can I write x? Right? And this Charles constant, it's going to be m. So I would say I got the equation in the form of y is equal to mx, and we already know what is the equation, what is the curve for y is equal to mx. It is going to be a straight line passing through the origin, right? This is the first curve which you guys are supposed to remember for the volume versus temperature in Kelvin for the Charles law. I'm sure you're clear with it. I'm sure you're clear with it. If you're clear with this graph, if you're clear with this curve, just hit the chat box with the thumbs up so that I get to know. Wonderful, wonderful guys. Great, 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 great. Akshita, you'll be getting the PDF. Definitely you'll be getting the PDF. Wonderful guys. Great, great, great. Wonderful, wonderful, wonderful. Wonderful guys. So let's move ahead and let's talk about one more graph related to the Charles law. Just have a look on what I'll be doing now. See, this was the curve between volume and temperature in Kelvin. This was the graph between volume and temperature in Kelvin for what? For the Charles law, right? Now people, talking about one more curve. That is going to be volume versus temperature in degree centigrade. What will be the nature of the curve? What will be the nature of the curve between volume and temperature in degree centigrade for the Charles law? Just tell me. I'm giving you some time. I'm giving you some time, guys. Just do it fast. Do it fast. I'm giving you some time. I'm giving you some time. Just tell me what will be the nature of the curve. What will be the nature of the curve? Jessica, I'll be giving you the Telegram link at the end. What do you think? What do you think? What do you think? Devaka, you'll be getting the significance of the laws at the end, okay? Okay, a lot of people are saying it's linear. A lot of people are saying it's linear. Have a look, guys. Have a look. Very, very simple thing. Right here, I'm going to plot the curve between volume and temperature in degree centigrade, right? Volume and temperature in degree centigrade. But what was our basic equation? If you remember, our basic equation is V is equal to, V is equal to K multiplied by temperature, and this temperature is in Kelvin. This temperature right here is in Kelvin, okay? Now, first of all, I have to plot a curve between volume and temperature in degree centigrade. But this temperature in my equation, it is in Kelvin. So what am I supposed to do? I'm supposed to change this temperature in Kelvin in temperature in degree centigrade, right? I'm supposed to change this temperature in degree centigrade. And I have already given you the relation in the last session, right? What was that? I have told you in the last session, temperature in Kelvin is always equal to temperature in degree centigrade plus 273.15. This is something which I have showed you in the last session. Okay, now what I'll be doing, have a look. I'll write simply V is equal to K multiplied by this temperature is in Kelvin, right? I'll use, instead of this temperature in Kelvin, I can use temperature in degree centigrade plus 273.15. I can use it, correct? Just multiply throughout by K. I'll be getting V is equal to K multiplied by temperature, and this temperature right now is in degree centigrade plus 273.15 K. This is what I'll be getting. Right? Now people, have a look simply. Right here, I'm plotting the volume along y-axis. Okay? I'm plotting the temperature in degree centigrade along x-axis. That's what I'm doing. I'm plotting the volume along y-axis. I'm plotting the temperature in degree centigrade along x-axis. So can you simply tell me, this volume, can I replace this volume? Can I replace this volume simply by y? I can say that, right? Y is equal to this temperature right here, it is in degree centigrade, and temperature in degree centigrade I'm plotting along x, right? So instead of this temperature, it's going to be x, correct? See, this is y, this is x, and over here I've got plus sign, and this 273.15 K, it is going to be my intercept, which I represent by C, and this K is going to be my slope, which I'm representing by M. Y is equal to mx plus C, and in the last session I've told you what is the nature of the curve for y is equal to mx plus C. That is the straight line. But will that straight line pass through origin? No, because I have got the intercept here, and the sign of the intercept is positive. That means the line is going to start above the origin. It won't be starting from the origin, right? Very, very simple. So the curve will be like this. Okay, and people, let me tell you one more time, the distance from the origin to the point where the curve starts, this is what we call as intercept, and intercept is represented by C, and C value over here is 273.15 K. So this distance, this intercept is going to be equal to 273.15 K. And what about the slope of the curve? What about the slope of the curve? Very, very simple. Slope means m value, and m value over here is equal to K. This is going to be your curve between volume and temperature in degree centigrade as per your Charles law is concerned. Just hit the chat box if you got it properly. Just hit the chat box fastly. Just hit the chat box with a thumbs up. Thank you, Gayatri. Thank you so much. Thank you so much. Just hit the chat box, guys. You'll be getting the PDF in the Telegram link. I mean the Telegram group. I'll be sharing the Telegram link at the end. Wonderful, guys. Wonderful. Great, great, great. Basically slope. Someone is asking about the slope. Slope means m value, and m value over here is K, right? Slope is m value and m value over here is K. That's why slope I have written equal to K. Okay, a lot of people are asking about the yesterday's answers. Yesterday's answers, PV versus P, right? That's a straight line. That's a straight line parallel to pressure axis. Similarly, PV versus V, that's again the straight line parallel to volume axis. Wonderful, wonderful, guys, wonderful. So let me move ahead and let's talk about few more curves related to the Charles law. Okay, I'm sure this part is clear. I'm sure this part is clear. Now what we are going to do is we are going to make one more curve. We are going to make one more curve as per the Charles law. Okay, one more curve, and this curve is between VT versus T. VT versus T. I'm giving you some time. Just have a look on the curve. Just tell me what will be the nature of the curve between VT versus T. Just fast. I want you guys to answer it in the chat box. Wonderful, guys. Do it fast. VT versus T. What do you think will be the nature of the curve? A lot of people are saying parabola. Okay, wait. Okay. Some are saying curve upwards, parabola, hyperbolic, y is equal to mx square. Okay, so let's have a look. Okay, one more guy is saying y is equal to mx minus c. So let's have a look on this curve as well, guys. See, now what am I supposed to do? I'm supposed to plot a curve between VT versus T. And this VT I'm plotting along y-axis. This VT I'm plotting along y-axis, and this temperature right here I'm plotting along x-axis, correct? I have told you, in order to make any curve, what am I supposed to do? I am supposed to use the basic equation, and the basic equation of the Charles law, we already know that is V is equal to KT. V is equal to KT. This is my basic equation. But just have a look. Along y-axis I have got VT, but over here I have got only V. So what am I supposed to do? Along y-axis I'm plotting VT, but over here I've got only V. So can I say I will have to multiply this equation throughout by T? I'll have to multiply this equation throughout by T, then only I'll get VT over here, and this is going to be KT square. Correct? I have just multiplied this equation by T. That's it. That's all what I've done. Now have a look. Instead of this VT, can I write Y? Correct? Instead of this VT, I can write Y is equal. Instead of T, I have to write X. So instead of T, I'm writing X, and over here we have got the square. So this is square, and K I'm keeping as such. Y is equal to KX square. People, do you remember in the last session I told you Y is equal to KX square? What is the nature of the curve for that? It is parabolic opening upwards, right? It is parabolic opening upwards, correct? I'm sure this graph, this curve is again clear to everyone. Just hit the chat box if you got this curve fast. Just hit the chat box with a thumbs up if you got this curve. Wonderful, guys. Great. Okay, a lot of thumbs ups are coming. That's what I want from you guys. Wonderful. So let's move on to one more curve. About the same, that is VT versus T square. What do you think will be the nature of the curve for VT versus t square. What do you guys think? What do you guys think? Again, I'm going to use the basic equation. What is my basic equation? That is V is equal to KT. This is my basic equation, right? This is my basic equation. V is equal to KT. But people, have a look. Along y-axis, I'm taking Vt. And along x-axis, I'm taking t square. Right? Along y-axis, I'm taking Vt. Along x-axis, I'm taking t square. But over here in this equation, I have got just V. I have got just V. So what am I supposed to do? I'm supposed to multiply this equation throughout by t. I'm supposed to multiply this equation throughout by t. So this is going to be Vt is equal to KT square. Right? Vt is equal to KT square. Correct? Now people, instead of this Vt, can I simply write y? Right? Instead of this Vt, can I write y? Now instead of this t square, instead of this t square, can I write x? So instead of t square, I'm writing x, and instead of this k, I'm writing m. Y is equal to mx. Y is equal to mx form. Do we guys know what is the nature of the curve for y is equal to mx? That is going to be the straight line like this, right? So this will be the curve for Vt versus t square. I'm sure this is clear to everyone. So let's move on to one more curve. Let's move on to one more curve, which you guys are going to tell me now. V versus 1 by t. What do you think will be the nature of the curve for V versus 1 by t? For V versus 1 by t. I want all of you to give the answer of this question. Fast. What do you think will be the nature of the curve for between V and 1 by t? Okay, Khushi is saying rectangular hyperbola. Divyanjali is saying linear. Yasmin is saying linear. Mohammad Rihab is saying something. Yasser is saying hyperbola. Okay, wonderful. Chandra is saying hyperbola. Wonderful. Okay, guys, have a look. Now, right now, I have to plot the curve between volume and 1 by t, right? Along y-axis, I'm keeping volume. Along x-axis, I'm taking 1 by t, right? Volume versus 1 by t. Very simple, correct? See, guys, what is my basic equation? V is equal to KT. V is equal to KT, right? Now just use a brain a bit. Have a look. Can I write it like this? V is equal to K divided by 1 by t. I can write it like this, right? I can write it like this. V is equal to K divided by 1 by t. This t will go again up. It will again become V is equal to KT. Correct? Now guys, have a look. This V I'm taking along y-axis. So instead of V, can I write y is equal to K? I'm writing as such, divided by, instead of this 1 by t, can I write x? So y is equal to k divided by x. Do you remember in the last session I have told you, whenever we need to plot a curve between two variables which are inversely proportional to each other, what is the nature of the curve for them? The nature of the curve is rectangular hyperbola. I'm sure you got it properly, right? If you got it, just hit the chat box with a thumbs up fast. Just hit the chat box with a thumbs up if you got it properly. Wonderful, guys. Great. Wonderful, guys. Wonderful. This is what I want from you guys. Now let's move on. Let's move on to one more important curve. V is equal to ln(t). This is ln of t. Okay, V is equal to ln(t). What do you think will be the nature of the curve between volume versus ln(t) for the Charles law? What do you think? I'm waiting for your answers. What do you think? V versus ln(t). What do you think will be the nature of the curve? Fast. Rahul, in the log, the base is 10. When I use ln, we use the base e. That's it. Thank you, Nandan. Thank you so much. Okay, Pavani is saying y is equal to minus mx plus c. Maybe, I have no idea about it. Maybe, I have no idea about it. Okay, let's plot a curve for this. Have a look. Have a look, guys. See. First of all, what is my basic equation? V is equal to KT. V is equal to KT. This is going to be my basic equation. V is equal to KT. Along y-axis, what am I plotting? I'm plotting volume. Along x-axis, I'm plotting basically this ln t. What does ln t mean? It means log of t to the base e, right? Ln t is basically log of t to the base e. That's what we call as ln t, okay? So along y-axis, I'm plotting volume. Volume. Along x-axis, I'm plotting ln of t. Correct? Now, people, let me tell you one thing. See, I can write this equation, understand properly. I can write this equation like this. V is equal to K multiplied by e to the power ln t. E to the power ln t. See, exponential and logarithmic, exponential and ln, e and ln, they eventually get cancelled out. Remember this, e and ln, they eventually get cancelled out. So it gets again converted into V is equal to KT, right? E and ln, they will get cancelled out, okay? So it will again come in the form of, V is equal to KT, okay? So what I have done simply is, V is equal to KT, I have converted it into this form, V is equal to K. I can write this T as e to the power ln t, okay? I can write it because e and ln will get cancelled out, I'll get T again, okay? Now have a look. Along y-axis, I'm plotting volume. So can I say instead of V, I'm writing y is equal to K, I'm writing as such. This is e to the power. Instead of ln t, can I write x? ln t, I can write x. Y is equal to K e to the power x. You would have studied in your class 11th physics. Y is equal to e to the power x curve. That's exponential increase. Right? So the curve is going to be like this. Exponentially it will increase, right? So this is the one more new curve between volume and ln t over here. Just people hit the chat box with the thumbs up if you got it. Fast. I'm waiting for you. Hit the chat box with the thumbs up. I'm waiting for you. Wonderful guys, wonderful. Great. Ln of t. Some people are saying, what is ln of t? Ln of t is nothing. Ln of t is basically log of t to the base e, right? You can write it like this. Log of t to the base e is represented by this ln t. That's it. Very simple. Okay? I'm sure this part is clear to everyone. Let's move on to one more. Let's see if there is one more curve. Yeah, there is one more curve. That is between log of V versus log of T. Now, guys, you people are supposed to answer me this one. Now, you people tell me what should be the nature of the curve between log of V versus log of T. I'm waiting for your answer. What do you think? Log of V versus log of T. Just hit the chat box with the answer. Yes, Rojan, I remember you, definitely. Hit the chat box with the answer. A lot of people are saying straight, a lot of people are saying linear, hyperbolic, slope, whatever I'm getting. Thank you. Okay, obtuse, inclined. Okay. Have a look, guys. Very simple it is. Very simple it is. See, I'm plotting this log of V along y-axis. Correct? I'm plotting this log of T along x-axis. Very simple. Log of V along y-axis, log of T along x-axis. Correct? What is my basic equation? We already know that V is equal to KT. Now, people, what am I supposed to do? See. Over here, along y-axis, I have got log of V. But in my equation, I have got only V. Correct? So what am I supposed to do? What do you think? I'll simply multiply this equation by log. So this is going to be log of V is equal to log of K multiplied by T. I can say that, right? I can do that. Now, people, it's almost done. So this is going to be log of V is equal to log of M into N. What is that? That is log of M plus log of N, right? Log of M into N is going to be log of M, which is log of K, plus log of N, which is log of T. Correct? Which graph are we supposed to plot? Between log V versus log T. Can I say instead of log V, I can use y, this is y, is equal. Instead of log t, I can write, or if you want to reshuffle this equation a bit so that there won't be any doubts at all, I can write it like this. Log of V is going to be equal to log of t plus log of k, right? I can write it like this. So instead of this log of V, I can write y. This is my y is equal to log of t. Instead of log of t, I can write x. So this is my x plus this log of k is going to be my intercept, and m value is going to be 1. Y is equal to mx plus c. Y is equal to mx plus c. You all know it. What is it? You all know it. Y is equal to mx plus c. It's a straight line. Will the straight line pass through origin? No way, because I've got the intercept with the positive sign. That means the curve is going to start above the origin, right? Very, very simple. So the curve is going to be like this. If I'll ask you, what is the value of intercept C over here? What is the value of intercept C over here? Intercept C is equal to log of k. If I'll ask you, what will be the slope of the curve? Slope of the curve, that means m value is equal to 1, correct? M value is equal to 1 over here, right? M value is equal to 1. If M value is equal to 1, slope is equal to 1. Slope is basically tan theta. Tan theta is equal to 1. Tan theta is equal to 1 means theta is equal to 45 degrees. So I will say this curve is making the angle 45 degrees with the positive x-axis in the anti-clockwise direction, right? Very, very simple. Just hit the chat box with the thumbs up fast. I want everyone to do it. Yes. Yes, these are based on NCERT. Yes. Wonderful, guys. Great. I'm liking it. Wonderful. Yesterday's homework, if you remember, PV versus P. It's going to be straight line parallel to pressure axis. PV versus V, again straight line parallel to volume axis. Wonderful, guys. Great. So let's move on to one more. Let me see if there is one more. Yes. We have got one more curve. We have got one more curve, guys. We have got one more curve over here. That is volume versus under root of t. Volume versus root t. V versus root t. What do you think? What do you think will be the nature of the curve between V versus root t? What do you think? I'm giving you some time. Just have a look on it. Oh, I missed a graph in between. Please check it. Okay, I'll check it afterwards. Okay. What do you think? Volume versus root t. What do you think? Yes. Any sort of curve they can give you in NEET exam, and they'll say which curve belongs to the Charles law, which curve belongs to the Boyle's law. Any curve they can give. A lot of people are saying parabola opening upwards. Okay. Aditi is saying, Prabhanchan is saying, okay. Iknur is saying rectangular hyperbola. Stark is saying hyperbola. Okay. Mary is saying parabola. Wonderful. Sakshi is saying parabola. Abhijit parabola. Okay. Mary is saying parabola. Likhita parabola. Okay. A lot of parabolas are coming. Let's check, is it actually parabola or not? Have a look. Along y-axis right now I'm plotting volume. Along x-axis I'm plotting root of t, under root t, right? Root of t, square root of t I'm plotting along x-axis. And we know, in order to plot any curve in the Charles law, what are we supposed to do? We are supposed to use our basic equation. What is our basic equation, guys? V is equal to kt. Right? V is equal to kt. See, along y-axis I'm plotting volume, and over here I have volume. But along x-axis I'm plotting root t. But over here I've got t. So what am I supposed to do? What do you think? Can I write this equation like this? V is equal to k multiplied by root of t ka square. Can I write it like this? Square and root will eventually get cancelled out. It's going to be same as V is equal to kt, correct? Very, very simple. Now. Along y-axis I'm plotting volume. So instead of this V, I'm writing y. is equal to K, I'm writing as such. Instead of root of T, I'm writing X. Instead of root of T, I'll be writing X. And this root of T as square, so Y is equal to KX square. People, do we know what is the nature of the curve for Y is equal to KX square? That is the parabolic opening upwards. Wonderful, wonderful. This will be our curve. Is it clear to everyone? Wonderful, guys. Great, great, great. Is it clear to everyone? Just hit the chat box fast. Hit the chat box with the thumbs up. Fast, 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 fast. Fast, guys, fast. Wonderful, wonderful, wonderful. I like it. Shalini, it's simple. It's simple. See, along y-axis I'm plotting volume. Along x-axis I'm plotting root t. So over here I have got v, but over here I have got t. So this t I have to convert in root t form. I can write, instead of t, I can write a root t ka whole square. That's it. That's it. So instead of e, I'm getting y. Instead of root t, I can write x, but this is root t ka square, so this comes square. Y is equal to kx square is the parabola opening upwards. I'm sure this is clear to everyone. Now people, someone of you have told me, I have missed one graph in between. Just tell me, what is that graph? No, everything is done, right? See, first we started with volume versus temperature in Kelvin, right? This is done. Then we did volume versus temperature in degree centigrade, right? This is done, right? Okay, then we did Vt versus T. This was also done. Vt versus T was also done, correct? Then Vt versus T square. This was also done. V versus 1 by T. This was also done. V versus ln T. This was also done. Log V versus log T. Again this one. V versus root T. All the curves are discussed, guys. All the curves are discussed. All the curves are discussed, right? All the curves are... Oh, you're saying third curve. Let me check the third curve. Which one is the third curve? This is the first one, right? This is again the first one only. This is the second one. We have made this. This again the second one only. This is again the second one only. This is the third one. Vt versus T. We have done this, right? We have done this. We have done every curve, guys. We have done every curve over here. We have done every curve over here. Okay? Now it's time for what? Gay-Lussac's law. Now it's time for Gay-Lussac's law. And what this Gay-Lussac's law is all about. What this Gay-Lussac's law is all about. Have a look, guys. Have a look. Let's check its statement first. Let's check its statement. What is its statement all about? This is now very, very simple, correct? We have made all the curves. Now you can make all the curves of Gay-Lussac's law as well. Have a look. For a given amount of gas, what does that mean? That means the number of moles of gas I'm keeping fixed, constant. At constant volume. Now, this law will be only valid if the volume of the gas is constant. If the volume of the gas I will keep fixed, if the volume of the gas I'll keep fixed, then only I can use this law. Pressure is directly proportional to temperature in Kelvin. Very, very simple. Have a look, have a look, have a look. I'm taking, for example, a container over here. Understand properly what I'll say, okay? I'm taking a container. This is my container. Okay, over here, I'm using a non-movable piston. I'm using a non-movable piston. I'm using a non-movable piston. Okay, now people, I have kept some gas inside the container. First of all, why am I using the non-movable piston? Because I want the volume of the gas to be fixed. I want the volume of the gas to be fixed. That can be only done if I'll be using the non-movable piston. Okay. Now people say, since the container is closed on all the sides, so number of moles of the gas is always also fixed. Number of moles of gas is also fixed, right? Constant, I'm saying. Number of moles of gas is also fixed. Volume is fixed. Number of moles is fixed. Now, can I use my Gay-Lussac's law? And what this Gay-Lussac's law is all about? Pressure of the gas is directly proportional to the temperature of the gas, but this temperature should be in Kelvin. And this is only valid if number of moles and volume of the gas are kept fixed. Correct? What do we mean by it? Simple. Both are directly proportional to each other, right? That means on increasing the temperature, the pressure increases. Correct? On decreasing the temperature, the pressure decreases. Which is very, very simple, which we can visualize from here also. See, the container, the volume of the container is fixed. The volume of the gas is fixed. Now people, if I increase the temperature, can I say on increasing the temperature, kinetic energy of gas molecules will increase? If the kinetic energy of gas molecules are increasing due to increase in temperature, can I say number of collisions will increase? And if number of collisions will increase, can I simply say pressure will increase? Very, very simple. So on increasing the temperature, kinetic energy of the gas molecules increases. And if the kinetic energy of gas molecules increase, I would say number of collisions will increase. And if number of collisions are increasing, I would say pressure of the gas will increase eventually, right? So I can say P is directly proportional to temperature. Pressure of the gas is directly proportional to temperature, but this temperature must be in Kelvin. Okay. Now people, have a look. Have a look. Let's try to visualize it a little bit mathematically. See. Have a look, guys. So what we got till now, we got to know that the pressure of the gas is directly proportional to temperature of the gas in Kelvin, provided what? Provided number of moles and volume of the gas are fixed, are constant. Right? Now people, can I remove this proportionality sign? I can do that. Very, very simple. So I'll be writing P is equal to, instead of proportionality, this constant will come, this comes as T, right? And this K over here is what we call as, Gay-Lussac's constant, right? This is what we call as Gay-Lussac's constant, correct? And this is the basic equation for the Gay-Lussac's law. P is equal to KT. Like we had in Charles' law, right? V is equal to KT. In the same way, we have got the basic equation of the Gay-Lussac's law as P is equal to KT, right? Now, people, I can make one more equation out of it. What? Very, very simple. Can I write it like this? P divided by T must be constant. P divided by T must be constant, right? I can say that. Let's remember this equation, okay? Why I'm remembering this equation? Very, very simple. Have a look. For example, I have got the container, okay, in which I'm using the non-movable piston. Why am I using non-movable piston? Because I want the volume of the gas to be fixed. I want the volume of the gas to be constant, fixed at all, okay? Let's say, first of all, the number of moles the container is closed on all the sides, so number of moles is already constant. Number of moles is constant and the volume of the gas is constant, fixed, right? Let's assume when the temperature of the gas was T1, let's say its pressure was V1. Let's say when the temperature of the gas was T1, its pressure was P1, okay? Can I say, as per Gay-Lussac's law, if I change any one of the parameter over here, the other will get automatically changed. Can I say that? Right? Because we know pressure is directly proportional to temperature. On changing the temperature, pressure changes, right? Now, people, the gas right now is at temperature T1, and when its temperature is T1, its pressure is P1, correct? Can I say, if I'll change the temperature from T1 to T2, if I'll change the temperature of the gas from T1 to T2, can I say its pressure will automatically change from P1 to P2? I can say that, right? Have a look. This is the initial state of the system. This is the final state of the system. This is the initial state of the system. This is the final state of the system. Now, can I write this Gay-Lussac's equation for the initial and the final state of the system separately? If I'm using this equation for the initial state, instead of P, I'll be using P1. So P1 divided by T1 will come as constant for the initial state, right? Similarly, for the final state, I would say P2 divided by T2 would come equal to constant. And from these two equations, I can conclude P1 divided by T1 is going to be equal to P2 divided by T2. But this equation, guys, this will be only valid when the volume and number of moles of gas are fixed, constant. Is it clear to everyone? Some people are asking, what is the value of this Gay-Lussac's constant? People, I didn't give you the value of Gay-Lussac's constant or Charles' constant till now, because for that, I need to give you the ideal gas equation, okay? When I'll use the ideal gas equation, when I'll teach you ideal gas equation, at that time, I'll give you the values of Gay-Lussac's constant and the Charles' constant as well, okay? Now, people, this is clear, right? This is clear. Wonderful. Great. Now, the curves which we made in the Charles' law, in the Boyle's law, in the same way, we are going to make few more curves over here. And what are the curves all about? See, now you can do any curve over here. Have a look, guys. The first curve is between pressure and, see how fastly you can make the curves now. See how fastly you can make the curves. See how fastly you can make the curves now. See, pressure versus temperature in Kelvin. What do you think? Pressure versus temperature in Kelvin. Oh, there is echo, huh? Okay. Is it fine now? Is it fine? People tell me, is it fine now? Oh my God, only no's are coming, huh? I think there is something wrong then. Is the voice coming proper now? Is it coming proper? There is echo. I'm checking my microphone only. I don't know what's wrong. Is it fine now? Is it fine? Oh, double voice is coming, it seems, huh? Okay. I have no idea like what's happening to it. There might be some technical glitch. So it's better we stop the session right now, okay? It's better we stop the session right now, and all the curves which we were used to, which we were supposed to do right now, we'll be doing that in the next session, right? It's okay guys, we can do the curves tomorrow, we can do these curves tomorrow, no issues at all. I'll start exactly from here, okay? Because at 4 you have got one more session, that is botany session by Himanshi ma'am, okay? At 4 sharp you have got one more session. Yeah guys, tomorrow we'll do. Tomorrow, if this is echoing, if the voice quality is not coming proper, we'll do it tomorrow, okay? We'll do all the curves tomorrow. I know you want me to carry on the session, but a lot of people are saying that the voice is not coming clear. Right? So we'll wait till tomorrow, and tomorrow we are going to do these. Anyways, can you just take the screenshot of it and can you let me know in the what is the nature of the curve for this P and T in the comment box afterwards? This is the first assignment for you. Pressure versus temperature in Kelvin. Anyways, tomorrow also I'm going to start from the same point, but take it as the assignment. Pressure versus temperature in Kelvin. Okay. Similarly, the second one will be pressure versus temperature in degrees centigrade. Okay, this will be our second. I want all the answers in the chat box. In the comment box. The third is PT versus T. Okay. The fourth is PT versus T square. Fifth is P versus 1 by T. Next is log P versus log T. Next is P versus root T. I want all of you to do these questions as the homework and let me know the answers in the comment box. I know guys the audio is not clear, that's why I'm stopping. Anyways, tomorrow I'm going to start from the same thing. Okay? Till now only then I need to take leave. Till then, bye-bye, take care, God bless you. I'll see you guys tomorrow. Okay? Telegram link is not working. Just see this Telegram link, guys. There will be a Telegram link in the description itself. Just click on that after the video. Okay? You'll get the Telegram link. Just click on that. You will get entered into the Telegram group which we have, where we share the PDF notes. Okay? Alright, it was nice meeting you. So, at the end, you all know what do we say? Do like, share and subscribe the channel so that everyone gets benefited. That's what I want from you guys. So see you tomorrow. Till then, bye-bye, take care, God bless you all and love you all. Bye guys, take care.